A single stone joint at 12,800 feet in the Bolivian Andes is so precise that for over a century, nobody has been able to slide a razor blade into the gap between two blocks. Not a coin, not a sheet of paper, a razor blade. On volcanic rock nearly as hard as steel, cut without a single piece of iron or bronze tooling, strong enough to scratch it easily, by a civilization that had no wheel, no written language, and no draft animals capable of hauling stone. When archaeologists and engineers finally measured these joints properly, using tools sensitive enough to catch deviations smaller than the width of a human hair, the numbers didn't just confirm what people had suspected for 100 years, they forced a harder question. Not whether this civilization was capable of something this precise, but how. Using nothing more than stone, sand, water, and time, they managed to pull it off at an altitude where the air itself fights against every hour of hard labor. This is the real story of Puma Punku, the strangest structure at the Tiwanaku archaeological complex in Bolivia. And what happens when you actually put rigorous science to work on a site that has been buried under a century of speculation. Puma Punku sits on the southern edge of Lake Titicaca, the highest navigable lake on Earth, on a wind-scoured plateau where the thin air holds roughly 40% less oxygen than it does at sea level. It was built by the Tiwanaku, a civilization that rose here around the year 500 CE and, at its height between roughly 500 and 1000 CE, controlled territory stretching from the Bolivian Altiplano into parts of what is now Peru, Chile, and Argentina. This was not a scattered collection of villages. It was a genuine state-level society with organized agriculture, long-distance trade networks, a distinctive artistic and religious tradition, and a capital city that may have housed tens of thousands of people. The Tiwanaku engineered raised agricultural fields that let them grow enough food at an elevation where farming should barely be possible, and they carved massive stone monoliths, including the Bennett monolith, which stands more than 20 feet tall, that are still on display today. Nobody in serious archaeology disputes that the Tiwanaku were real, organized, and remarkably capable. What has been argued about for well over 100 years is something narrower. Whether their own tools and their own documented methods can actually explain the specific precision found at one particular structure, a quarter-mile from their main temple complex, called Puma Punku. That kind of state-level organization didn't appear overnight, either. The archaeological record shows the Tiwanaku culture developing gradually over centuries, growing out of smaller farming communities scattered around the lake before slowly consolidating into the regional power it eventually became. That matters more than it might sound like at first, because it means the stoneworking skill on display at Puma Punku wasn't invented by one especially gifted generation. It was refined, tested, and passed down across many generations of craftsmen working within an increasingly centralized and increasingly wealthy state, one with the surplus food, the labor pool, and the administrative capacity to support specialists who did nothing but work stone for a living. A society with that kind of accumulated institutional depth looks considerably more capable of pulling off something like Puma Punku than a smaller newly formed community would. The difference between Puma Punku and the rest of the Tiwanaku site is immediately obvious to anyone who visits. The main complex, with its terraces, walls, and ceremonial platforms, is impressive, but it looks like what you'd expect skilled builders of this era to produce. Puma Punku looks like something else entirely. Its blocks, cut from andesite, a hard volcanic rock, and from red sandstone, are carved with flat faces that stay flat across several feet, with interior corners that meet at angles repeating almost identically from one block to the next, and with grooves and notches cut so cleanly that some of them appear less like hand carvings and more like they were produced from a shared template. This is exactly the kind of consistency that suggests standardized tools, standardized measurement, and a system, rather than one especially gifted craftsman working alone. The first person to take this seriously, in a scientific sense, was Arthur Poznański, an Austrian-Bolivian engineer who spent more than 50 years of his life studying the site in the early 20th century. Poznański is a complicated figure in the history of this research, and it's worth being honest about why. He is best known today for an extraordinary claim that certain alignments at the site pointed towards specific solstice positions and stellar risings, and that by calculating backward through the slow wobble of Earth's axis, the original construction could be dated to somewhere around 15,000 years before Debug. He present. That date has been rejected by essentially the entire archaeological community. Radiocarbon dating of organic material recovered from construction layers at the site consistently places the building of Puma Punku between roughly 500 and 1000 CE, squarely within the known Tiwanaku period, with some of the tightest carbo end dates clustering around the 6th century CE. Poznański's astronomical method has also been criticized on more technical grounds, including uncertainty about which structures he chose to measure his alignments against, and whether centuries of earthquakes, looting, and shifting foundation stones had already thrown those alignments off long before he arrived with his instruments. But here's the part of Poznański's work that didn't age nearly as badly. His raw physical observations, his careful documentation of how flat the surfaces were, how consistently the angles repeated, and how tightly the joints fit together, turned out to be remarkably accurate. Decades later, when other researchers came back with far better equipment, they kept arriving at strikingly similar numbers. And that's an important distinction to hold on to through the rest of this story. The mystical dating was wrong. The stonework observations were largely right. That brings us to the material itself, because the choice of andesite is one of the more genuinely puzzling decisions the Tiwanaku made, and understanding why requires a little bit of basic material science. Andesite is a volcanic rock that sits around 6 to 7 on the Mohs hardness scale, the standard scale geologists use to compare how easily one material can scratch another. Copper, by comparison, sits at around 3. Bronze isn't dramatically harder. That gap matters enormously because it means that any copper or bronze cutting tool pressed against andesite wears down faster than the stone does. You cannot efficiently chisel or saw through andesite with metal tools from this period. Something else has to be doing the actual cutting. The explanation that is held up under decades of scrutiny, and this is where the story gets genuinely interesting, comes from experimental archaeology rather than speculation. In the 1990s, researchers Jean-Pierre Protzen and Stella Nair, both working out of the University of California, Berkeley, set out to actually test whether Tiwanaku level precision was achievable using only Stone Age technology. Rather than theorizing from a distance, they went out and tried to replicate it. Protzen focused on the flat surfaces and demonstrated that they could be produced through grinding, using flat abrasive stones dragged repeatedly across the andesite surface along with wet sand acting as a cutting compound. It's a slow process. Protzen's own estimates suggested that producing a single, large, flat, polished surface this way could take an enormous number of hours, but the technique works. And it leaves exactly the kind of subtle, repetitive abrasion marks that show up on the real blocks at Puma Punku, rather than the smooth, featureless finish a powered tool would leave behind. It's also worth pointing out that this exact grinding and polishing technique wasn't unique to the Tiwanaku. The Inca, who rose to power centuries later and eventually absorbed the remnants of Tiwanaku territory into their own empire, used strikingly similar methods at sites like Ollantaytambo and Sacsayhuaman, both in the region around Cusco in modern Peru. Protzen studied those sites too and found the same signature: rough hammerstone shaping followed by slow, deliberate abrasive grinding, producing joints so tight and surfaces so flat that they're still regularly cited alongside Puma Punku as the finest stonework anywhere in the pre-Columbian Americas. That consistency across two different cultures, separated by centuries, working independently but arriving at similar solutions to the same physical problem, is itself a strong argument that this was a known, teachable Andean stoneworking tradition, not a one-time fluke or technique borrowed from some unexplained outside source. Nair pushed the experiment even further. Using nothing but stone tools, flint, obsidian, quartzite, and hematite, she successfully carved a cross-shaped design roughly 8 inches across into a block of andesite, reproducing sharp interior corners, clean edges, and dimensional accuracy comparable to what's visible on the real 8-shaped blocks at the site. In other words, this wasn't a thought experiment. It was hands-on proof that a technically skilled person, using only materials the Tiwanaku definitely had access to, could produce this exact style of precision work. That single result did more to settle the how question than a century of theorizing had managed. The rougher shaping almost certainly started even earlier in the process, with hammerstones, dense stones like diorite, which is roughly comparable in hardness to andesite, used to repeatedly strike and slowly pound away material from the block being shaped. This same basic technique shows up at other precision stoneworking sites around the ancient world, including the granite quarries at Aswan in Egypt, where an unfinished obelisk still bears the rough, pitted surface marks left behind by exactly this kind of percussion work. At Puma Punku, that pounding stage would have roughed out the basic shape of each block, and then grinding with sand and water would have taken over to bring the surfaces down to their final, startlingly flat finish. Here's where the numbers become genuinely hard to dismiss. Protzen and other researchers who have measured the finished joints at Puma Punku describe fits so tight that a standard razor blade cannot be inserted into the seam between two separate stones. Not paper, not a coin, a razor blade. That's not folklore or exaggeration past. Down through pop science articles, it's a documented physical observation from researchers who have run their hands and their instruments over these joints directly. The largest of the surviving platform blocks, made from red sandstone rather than andesite, is genuinely massive. One measured block runs roughly 25.5 feet long, 17 feet wide, and 3.5 feet thick, and is estimated to weigh somewhere in the neighborhood of 130 tons. These sandstone giants were quarried and dragged roughly 10 kilometers from a source near the lake, up a meaningful incline, while the smaller andesite blocks used for the finer, more precise H-shaped elements came from quarries on the Copacabana Peninsula across the lake, roughly 90 kilometers from the site. Moving stone of that scale across Andean terrain, without wheels, without draft. Animals capable of hauling that kind of load, and without iron tools, required an enormous, carefully organized logistical operation involving sledges, ropes, log rollers, and a labor force large enough and well-fed enough to sustain months or years of this kind of physically brutal work at nearly 13,000 feet above sea level, where every hour of exertion costs the human body significantly more than it would at the coast. The H-shaped blocks specifically, the ones this video's title references, deserve their own explanation because their design isn't just decorative. Each one is cut with matching protrusions and recesses designed to interlock with its neighbors, creating a structure that could theoretically be assembled without any mortar at all, held together purely through the geometry of the stones themselves. Researchers who have modeled this interlocking system have proposed that it wasn't just an aesthetic choice. It appears specifically engineered to help distribute stress during earthquakes, which are common across this stretch of the Andes. Simulations of this kind of interlocking joint suggest it can meaningfully reduce shear forces compared to a simple stacked wall, which would mean the people who designed this system were thinking seriously about long-term structural survival in a seismically active landscape, not just about how the finished building would look. Similar interlocking strategies appear at other sites across the Andean world too, which suggests this wasn't a one-off trick unique to Puma Punku, but part of a broader regional engineering tradition focused on earthquake resistance. It's worth pausing here to talk about how researchers actually measure claims like these today, because the tools matter as much as the stone does. For most of the 20th century, the best available instruments were calipers, straight edges, and simple optical levels, tools capable of detecting variation down to maybe a millimeter under good field conditions. That's genuinely useful. It's more than good enough to notice that a surface is unusually flat or that an angle looks suspiciously consistent. But a millimeter of uncertainty is also large enough to hide the exact difference between careful, skilled handiwork and something that would require an entirely different explanation. Over the past 2 decades, heritage science as a field has increasingly turned to far more sensitive tools to close that gap, including laser scanning, photogrammetry, and structured light scanning, the same underlying technology aerospace and automotive manufacturers use to verify that a physical part meets its design specification down to fractions of a millimeter. These techniques have already been applied at other precision stoneworking sites around the world, and as that kind of equipment becomes cheaper and more portable, it's increasingly likely to make its way to remote high-altitude sites like Puma Punku as well. When it does, it won't be looking for evidence of some undocumented lost technology. Based on everything the existing research already shows, it's far more likely to simply confirm, with more decimal places than ever before, just how disciplined the Tiwanaku's stone-on-stone methods really were. Now, it would be dishonest to walk through this story without addressing the fringe theories that have attached themselves to this site over the decades, because they're a significant part of why Puma Punku has the reputation it does. The most persistent alternative claim, popularized more recently by the French materials scientist Joseph Davidovits, argues that these blocks weren't carved from solid stone at all, but were cast, essentially poured into molds using some form of ancient geopolymer, a synthetic stone-like material. It's a genuinely interesting hypothesis on paper, and Davidovits has published research defending it. But petrographic analysis, examining thin slices of the stone under a microscope, and mineral sampling that matches the blocks directly against known andesite quarry sites several kilometers away, has consistently shown that these blocks are naturally formed volcanic rock, with the same crystalline structure you'd expect from stone that cooled and solidified underground over geological time, not from any kind of poured or cast material. The vast majority of geologists and archaeologists who have examined the site do not support the cast stone theory. It's also worth being slee-eyed about claims involving drill holes supposedly showing signs of rotary power tools, or precision described as flatly impossible for hand methods. Pratzen and Nayer's experimental replications directly undercut the word impossible. Difficult? Yes. Extraordinarily time-consuming? Yes. Impossible? No. So if the stonework itself isn't the true mystery anymore, what actually is still unresolved about Puma Punku? This is the part of the story that rarely gets the attention it deserves because it's less flashy than claims about ancient super technology. But it's the genuinely open scientific question. Puma Punku has been looted and dismay, handled for roughly 500 years. Spanish colonizers pulled blocks from the site to reuse as raw building material. Local communities carted off stones for their own construction over the centuries that followed. Earthquakes, the very forces this interlocking design seems to have been engineered to resist, still toppled sections of the structure and scattered pieces across the plateau over time. Of the roughly 150 blocks believed to have made up the original standing architecture, not a single one remains in its original position today. What's actually left at the site is closer to a debris field than a ruin, a scattered stone puzzle with a meaningful number of its pieces damaged, missing, or relocated entirely. And Spanish colonial accounts from the 16th and 17th centuries even describe the structure as an unfinished, though still wondrous, building. That's exactly the problem the most serious modern research effort at Puma Punku has actually been trying to solve, and it comes from archaeologist Alexei Vranich and his team, first at UC Berkeley and later at UCLA. Rather than chasing more dramatic claims about how the stone was cut, Vranich focused on a much harder and much less glamorous question. What did the original structure actually look like standing? His team spent years compiling and reconciling roughly a century and a half of scattered measurement data, going all the way back to 19th century field notes and hand-drawn sketches from early researchers, along with far more rigorous measurements taken in the 1990s by Protzen himself, because most of these stones are simply too large and too heavy to move or handle directly. Vranich's team took what sounds, at first, like a surprisingly low-tech approach. Instead of relying purely on computer modeling on a screen, they 3D printed accurate miniature replicas, 140 pieces representing the andesite, superstructure, and 17 slabs representing the sandstone foundation, all scaled down small enough that researchers could actually pick them up, rotate them by hand, and physically test different ways the fragments might have originally fit together. Vranich has explained that this wasn't a step backward from digital methods so much as a recognition of something practical. The human brain is still better than a computer screen at intuitively manipulating irregular three-dimensional shapes in space and giving researchers physical models to handle, let them explore possible arrangements far faster than screen-based modeling alone allowed. Their work, published in the journal Heritage Science in 2018, produced one genuinely striking insight along the way. Doorways of different sizes, scattered separately across the site, turn, add out to align in a way that would have created a deliberate mirror effect, giving a viewer standing in a single room the illusion of looking into infinity. That's not the kind of detail you stumble into by accident. It suggests a level of architectural intent that goes well beyond simple utility. Even with that progress, a fully confirmed complete reconstruction of Puma Punku still hasn't been achieved. Some of the surviving fragments pair up cleanly with obvious neighbors. Others show slight but real variations in dimension, differences that might indicate separate production batches made to slightly different specifications over time, or might simply reflect the fact that too many connecting pieces are missing for the full picture to click into place using only what survives today. That uncertainty is exactly why serious researchers remain cautious about declaring any single reconstruction final, and it's part of why active work on the site continues, rather than being treated as a closed case. One idea that occasionally surfaces is whether Puma Punku was simply left unfinished, its blocks manufactured and hauled to the site, but never fully assembled. And there is some historical support for that possibility in those early Spanish accounts describing it as incomplete. But there's no clear evidence of a sudden catastrophic event that would explain an abrupt abandonment. The Tiwanaku state didn't collapse overnight. The available evidence points instead to a slow generational decline, likely tied in part to a prolonged regional drought, eventually fragmenting into smaller groups that were absorbed into the expanding Inca Empire centuries later. That kind of gradual decline doesn't obviously explain a single construction project being abandoned mid-assembly, which is part of why many researchers still lean toward viewing the site as substantially built and later damaged and scattered, rather than one that was never completed at all. It's a question that, honestly, remains genuinely open. It's also worth remembering just how physically demanding this entire undertaking was, independent of the stonework itself. Modern studies of high-altitude labor consistently show that people working at elevations comparable to Puma Punku's nearly 13,000 feet tire faster and require significantly more recovery time than workers doing identical physical tasks near sea level, simply because there's less oxygen in every breath. That means the actual number of person-hours required to quarry, transport, shape, and finally place blocks weighing tens of tons, some close to 130, would have been substantially higher here than an equivalent project built somewhere closer to the coast. Pulling that off wasn't just a matter of skilled stoneworkers, it required an entire supporting system behind them, enough agricultural, surplus to feed large labor crews over extended periods, a command structure capable of coordinating quarrying, transport, and construction as separate but connected phases of one long-running project, and enough institutional continuity to keep that effort moving forward across what was like Cayley years, possibly decades of sustained work. That's exactly the kind of centralized organizational capacity that historians already associate with the Tiwanaku state at its peak, which is part of why the full picture of Puma Punku fits comfortably within what's already known about this civilization, rather than requiring anything beyond it. Zoom out far enough, and Puma Punku fits into a pattern that shows up again and again across archaeology. Modern researchers repeatedly underestimate what ancient societies were capable of, right up until better tools force a correction. Airborne laser scanning of the Central American jungle in the past decade revealed Maya cities far larger and more densely populated than anyone had previously assumed possible. Careful, modern. Remeasurement of Egyptian stonework has revealed tolerances that genuinely surprised contemporary engineers. In every one of these cases, the actual lesson wasn't that some undocumented, mysterious predecessor civilization was secretly responsible. The lesson was that skilled ancient societies, given enough organization, enough accumulated generational knowledge, enough patience, and enough coordinated labor, could produce results that look almost implausible from a distance, right up until researchers measure the evidence carefully enough to actually explain it. There's also a structural detail about the H-blocks worth sitting with a little longer, because it's one of the clearest signs that this was engineering, not just artistry. Even accounting for how scattered and incomplete the surviving collection is, researchers have noticed that the blocks don't all fit together with identical dimensions. Some pair up cleanly, matching almost perfectly. Others show small but measurable variation, hundredths of an inch here, a slightly different groove depth there. Rather than undermining the precision story, that kind of variation is actually consistent with what you'd expect from a large, long-running construction project carried out over years, possibly by different work crews or during different construction phases, each following the same design standard, but with the ordinary small variations that come from human hands, repeating a process thousands of times. Perfect, machine-identical uniformity across 150 separate blocks would arguably be a stranger finding than the small, human-scale variation that's actually there. That's really the honest, complete picture of Puma Punku. The precision is real, and it's remarkable by any standard, ancient or modern. But it's explainable through a documented, testable combination of hammerstone percussion, patient abrasive, grinding with sand and water, careful standardized measurement, and an enormous, well-organized labor investment sustained across years, at an altitude that made every single hour of that labor more punishing than it would have been almost anywhere else on the planet. What genuinely isn't resolved yet is the assembly, which blocks originally connected to which, what the completed structure or structures actually looked like while still standing, and how a construction project this sophisticated was planned, staffed, and managed across however many years, possibly decades, it took to complete. The Tiwanaku people didn't need lost technology to build Puma Punku. They needed exactly what the archaeological and experimental evidence says they had. Generations of accumulated stoneworking skill, a centralized state capable of organizing large coordinated projects, and the patience to grind volcanic rock down to a tolerance a modern machinist would recognize as genuine engineering precision. The blocks are still sitting exactly where 5 centuries of looting, earthquakes, and time left them, scattered across that wind-swept plateau above Lake Titicaca, their surfaces holding tolerances tight enough to satisfy modern manufacturing standards. Their original arrangement, still an open question that researchers are working through one measurement, one printed fragment, and one carefully tested configuration at a time. The mystery of Puma Punku was never really about whether this level of precision was possible. It's about what these people built with that ability, and how it all originally stood together before time and human hands slowly took it apart. If this kind of deep dive into the real evidence behind ancient engineering is something you want more of, subscribe and turn on notifications, because there are plenty more sites out there with reputations built on speculation and stories that deserve to be told with the actual research behind them. And if you have thoughts on what Puma Punku might have looked like standing, or which ancient site you want covered next, drop it in the comments below. I read all of them.